Yeah, good day class. I'm back again. So we are going to take an example with the application of the Roy's identity so that we can be able to derive the Marshallian demand functions or the ordinary demand functions for commodity X and Y. So now what we have here is an indirect utility function. It is an indirect utility function in the sense that we have V, which is the indirect utility function, as a function of income, price of X, and price of Y. So now we're going to take the partial derivative of V with respect to Px, V with respect to Py, V with respect to M. But before we do that, X and Y are in the denominator. So we must do some manipulations in such a way that X and Y, that is Px and Py, will be back to the numerator. Now, we have V equals M over 2Px raised to the power of half, Py raised to the power of half. This can be written as V equal to 1 over 2 times M over 1 times 1 over P x raised to the power of half times 1 over Py raised to the power of half. Now this can also be written as V equals 1 over 2 times M over 1 times P x raised to the power of negative half over 1 times Py raised to the power of negative half over 1. This is because, according to the laws of indices, a number x raised to negative power 1 is equal to 1 over x. That implies that 1 over Px raised to the power of half is the same as Px raised to the power of negative half. Now, this can be written as V is equal to 1 times M is M times Px raised to the power of negative half, Py raised to the power of negative half, all over 2. Now this is a redefined indirect utility function. Now from here, we are going to take the partial derivative of V with respect to M, with respect to Ps, and with respect to Py. Now to do that, we have, it caught me. The partial derivative of V with respect to income. The power of M here is 1. So that is 1 times 1 over 2 times M raised to the power of 1 minus 1, Px raised to the power of negative half, Py raised to the power of negative half. Now this will give us partial derivative of V with respect to M will be equal to 1 over 2 times M raised to the power of 0 times Px raised to the power of negative half times Py raised to the power of negative half. Now any number raised to the power of 0 is 1. So what we have now is the partial derivative of V with respect to M is now equal to 1 over 2 Px raised to the power of negative half, Py raised to the power of negative half. So this is the partial derivative of V with respect to M. The same thing applicable to the partial derivative of V with respect to Px which is equal to 1 over 2 times 1 over 2 times m times px raised to the power of negative half minus 1, then times py raised to the power of negative half. Now this can be written as, we are taking a partial derivative, so we're supposed to multiply here by 1 over 2. So what we have now is 1 times 1 is 1, 2 times 2 is 4. Then times m ps raised to the power of negative half, negative 1. This 2 times 1 is 2. Negative 1, negative 2 is negative 3. It is negative 3. We have a partial derivative of v with respect to ps is equal to 1 times 1 is 1, 2 times 2 is 4. Then mpx raised to the power of negative 3 over 2, py raised to the power of negative half. So this is the partial derivative of v with respect to ps. So the partial derivative of v with respect to py will be equal to 1 over 2 times 1 over 2 times m ps minus half times py minus half minus 1. Now this will give us the partial derivative of v with respect to py will be equal to 2 times 2 is 4, 1 times 1 is 1 over 4. Then mpx raised to the power of negative half, py raised to the power of negative 3 over 2. So now we have succeeded in getting the partial derivative of v with respect to m, v with respect to ps, v with respect to py. So now to get the Marshallian demand function for x and y using the Roy's identity. For x, the Marshallian demand function for x is equal to the negative partial derivative of v with respect to ps over the partial derivative of v with respect to income as a result of substitution. The partial derivative of v with respect to ps, look at the answer here. We have negative 1 over 4 mpx raised to negative 3 over 2 py raised to negative 1 over 2 all divided by the partial derivative of v with respect to income, which is 1 over 2 px raised to negative half, py raised to negative half. Now, py raised to negative half, we cancel py raised to negative half. 2 into itself 1 time. 2 here 2 times. So what we have is, now let's not cancel the 2 first. Let's leave the 2. So what we have here is x is equal to 1 over 4 m times. But this can be written as px raised to the power of negative 1 over 2, px raised to the power of negative 1, laws of indices. All divided by 1 over 2, px raised to the power of negative half. In such a way that this will go with this. Then what we have is 1 over 4m px raised to negative half, negative 1, then divide by 1 over 2. This can be written as 1 over 4m raised to the power of, 1 over 4m px raised to the power of negative 1 times 2 over 1 in such a way that 2 cancel, is 1 times 2 here 2 times. So the Marshallian demand function for x is now equal to 1 over 2 m px raised to negative 1, or x raised to the power of m, which is the Marshallian demand function for m, is equal to 1 over 2 m times 1 over px, which is the same as m over 2 ps. So the Marshallian demand function for commodity X is equal to m over 2 ps. Now the Marshallian demand functions are identical. If you are running with shortage of time, if you are in a hurry, to get the Marshallian demand function for the next commodity, you just change this one to y. Well, let's try it out. Now for commodity y, the Marshallian demand function for commodity y raised to the power of m, is equal to negative partial derivative of v with respect to py, the partial derivative of v with respect to m. This is equal to the partial derivative of v with respect to py is 1 over 4 mpx raised to the power of negative half py raised to the power of negative 3 over 2, all divided by 1 over 2 px raised to the power of negative half py raised to the power of negative half, in such a way that px raised to the power of negative half we cancel ps raised to the power of negative half. Then what we have is the Marshallian demand function for y is equal to 1 over 4m py now py raised to the power of negative 3 over 2 is the same as py raised to the power of negative half py raised to the power of negative 1 is the same thing with the laws of indices. This thing is the same. So with this, we have py raised to the power of negative 1 over 2 py raised to the power of negative 1. Then divide by 1 over 2 times py raised to the power of negative half, in such a way that if we take the reciprocal here, we have the Marshallian demand function for y will be equal to 1 over 4 will be equal to 1 over 4 mpy raised to the power of negative half py raised to the power of negative 1 times 2 over 1 times 1 over p y raised to the power of negative half, in such a way that this will go with this. 2 here 1 time, 2 here 2 times. So that we have y raised to the power of m is equal to 1 over 2 times m times py raised to the power of negative 1. We take the reciprocal, this one is over 1. This one 2 over 1. We take the reciprocal, you have 1 over 2 times m times 1 over py. Now if we multiply the numerator, 1 times m times 1 will give us M. Then 2 times Py will give us 2Py. So if you can look at it very well, discover that the Marshallian demand function for X is M over 2Px. The Marshallian demand function for Y is M over 2Py. So the Roy's identity can actually be used to find the ordinary demand functions or the Marshallian demand functions directly using the indirect utility function, not as the Lagrangian multiplier where you have a direct utility function. When you have an indirect utility function, you can as well solve for the Marshallian demand function. Thank you so much for watching this video. Please like, share, and comment, and do well to contact me for more recent videos that will suit your current study level. Thank you so much for watching. So, how many minutes?